Hello everyone, welcome back to my Solidworks bootcamp, 1 week bootcamp, and it's an online bootcamp. And you all are welcome onto the day 4, where we are going to learn and continue our learning about Solidworks part modeling, and we'll do more design practices. So, if you remember, in the last session, we have started into different 3D modeling tools and features. And in this video we are going to continue that learning, and I hope all of you have, if you have any questions, you can ask in the upcoming live sessions. And apart from that, keep practicing on yourself, on your SolidWorks, on your PC, on your computer. So whenever you got any questions, you can drop that question into the WhatsApp group as well until this boot camp. And we already posted few assignments. I don't know how many of you have already completed those assignments, but we already posted few assignments, and I expect that some of you have already submitted and some of you are doing, but that is not mandatory, that is not compulsory. It's completely your choice. As you can see onto your screen, for the day 1 we already have this assignment, and also the recorded session have been uploaded. Same for the day 2, assignments and recordings uploaded. For the day 3 also, assignment and recording has been uploaded. Now we are on day 4, so very soon this recording will get uploaded, but the assignment is there where you have to make this part, and this is the part that I am going to show you how you can make this part. And you have to finish the same by following this video, and in the next upcoming session, that is on day 5, we'll assemble all the parts together. So it's super important, it's very important that you finish this part at least at your end. So let's move back to our SolidWorks. We'll open the SolidWorks and we'll see. And again, I'm repeating, anytime if you have any questions, just write that into the WhatsApp group, or you can also drop your questions anywhere onto social media. Just tag me onto your social media, I will answer that. You can ask a question on LinkedIn and tag me for your queries and question. I will, whatever uh, is possible, I will try to help you. And so here you can see right now we are inside SolidWorks, and in the last video we have finished few things that I'm going to share you right now. So if we'll go on to the file menu, okay, let's go to the home, and here you can see in the history you can see all the parts that we have worked so far. So let's open this main part, solid body part that we have finished. So it will take few seconds to load because SolidWorks is a very industrial grade software. So, and sometimes it takes little bit of time to load the part. So this is the part that we have finished in our last class, in our last session. And in the last session, the only thing that we have not applied, I think, is the thread that you can see at the bottom. So this thread, I don't think we have applied on the last session, but rest of the parts we have completely finished into the last session. So let me start with the thread. First, I will delete these two features so we can start making the thread. I will delete it. So now here you can see we just deleted it, and now let's start making the thread onto the bottom face first. So as we know, if you want to start creating any feature on any face, we can start that. But here, since we want to add a hole onto this face first where we'll create a thread, so for that, what we'll do, we'll go on to the features tab first, and then here you will find a whole wizard tool, right? Just expand that drop down menu, and you can see there are lots of options. So from all these options, I will select this hole wizard because we want to create a hole first, a hole of diameter, I think 12 millimeter. So we'll do that first. So we'll activate the tool, and moment we'll activate the tool, you can see it comes with different type of holes. So if you want to create a normal hole like a consistent diameter, you always have to select this option that says hole, simple hole. Whereas others are different types of holes like countersunk hole. Here you can see the counter bore hole. But For normal hole, always select this option. Here you can see it's activated. Now once you selected this option, we'll select the standard. So in most cases, if you are based in Asian countries, we'll select ISO only. But if you are in European or American countries, you can select standard as per your country. But here we mostly work with ISO, that is International Standard Organization. So it's applicable, that the features that we select is applicable in almost all the countries. And then we'll go on to the type, where we'll keep the dowel holes, because for holes you always have to keep these dowel holes. Now the size, diameter for this hole we want to keep 12. So we have these all these options. So why we are using this hole tool to create this hole? Because uh, how we can create hole, there is a single process. Like first you have to use a drill tool. By using the drill tool you can make a hole onto your metal body, right? Otherwise you cannot make a hole. Like if we created a circle onto this face and extrude cut, that process is not applicable, because here you can see the standard drill bit sizes are available in these sizes only. So if we have a drill machine and we want to make a hole of 13 millimeter, it's not possible, because we have the standard drill sizes in ISO standard is only 10 and 12. There is no uh, hole sizes of around 11 and 11 millimeter diameter or 13 millimeter diameter. So for that, that's why we use this whole feature. So because whatever designs we are producing, we are making, the end goal is to get them manufactured, right? So if it is not manufacturable, we cannot find the tools to manufacture that feature, then there is no sense of adding those features into your design or drawing. That's why we follow a correct approach, this whole tool. So here I will define 12 millimeter, and then in the end condition it is up to next. Now we have to define the position of the hole, where at which position on this face we want to create our hole. So for that we'll go to this move position panel, and here where it is saying me that whether we have the existing sketch that we want to select, right? Or we want to create a 3D sketch. So I will, yes, I want to create a 3D new 3D sketch. So I will simply select the face, right? So you can see the moment I selected the face, this face is ready to start creating a sketch. So I will randomly define and click anywhere onto this. So here you can see the hole just got created somewhere onto this face, right? Even if we'll rotate little bit, you can see onto this face the hole is getting created at this point. This is just a preview. Once we'll apply the OK, it will apply this tool feature. So right now it is just a preview. But before that, I also want to define the position of this hole. So for that, we'll go to the normal again. We'll activate this smart dimension tool, and from this side to the center I want to keep 20, right? So I'll enter 20. Also I want this point, I'll press escape first, and then escape, come, I will come out of the dimension tool. So and then we'll select this point and this point. I will make sure that these are two horizontally aligned. So we'll apply this horizontal constraint between these 2 points, and we'll click on finish. So now you can see we have defined the position of the hole. Now we'll go back to the type option and we'll click on the finish. So what we did, we have applied a hole of 12 diameter onto this face. But here you can see when I am rotating, the hole is little bit more towards the fillet. So we have to move this whole position little bit toward the right. Like if you'll see in this view, we have to move this hole little bit towards the right area. So for that, we'll go back to the command again. We'll expand it and we'll find that sketch. So this is the sketch. This is the sketch we use to create this hole, and this is the sketch for the position of the hole. So we'll edit the this one, because sketch 5 is for the position of the hole. You can see the point. So we'll make a right click, we'll click on edit sketch. Now instead of 20, I will double click on it and we'll change this to 15. Here you can see the hole just got shifted towards the required position. Now we'll click on finish, exit sketch, and here you can see the hole just got updated, and now it is on the right place on the right location. Here you can see. So this is how we added a hole using the hole feature, using the hole wizard command inside SolidWorks. And anytime if you want to change the hole size, make a right click onto this command, click on edit feature, and we'll able to see the same panel from where you can change the hole sizes as per your required values. But here I will keep 12 and will click on finish, right? So this is how you can add holes to your tool. Now once we drilled the object and we created the hole, the next thing, if you want to add a thread onto the internal uh, circumference or the face of this hole, we have to use the tapping tool to create that thread, right? So for that, again, for that, to do that thing, we have this tool called, just go into the hole wizard and activate this tool called thread, right? Activate this tool, thread, simple tool. Activate the tool, press ok. Now here you have to define the face onto which you want to apply your thread. I will select this internal face. Let's select the internal face. First click over here and then select this edge, sorry, not the face, just select the edge, because we have to define a edge from where the this thread will start. So I selected that edge. Now after that you have to go to the end condition, that should be blind, right? So if it is blind, this means the thread will get created to up to the complete surface, like to the other end of the that surface. In the next thing, that we have to define like which kind of thread we want to use. So we'll use the metric die, because since we are using millimeter gram second system of units, so we'll use the metric die. Now the size, here you can see the size is right now M20, but the hole we created is M12. So it's not right, so we'll change this to M12. M12, in M12 we have variety of thread options. So let's take this M12 into 1.5, right? So we took M12 into 1.5, and right now you can, in the preview you can see the threads are getting added onto this direction. But again, that is not right. It should be engraved inside the body, right? Here you can see it should be engraved inside the body. From this corner you can see it is extending from the body, but it's not possible. So what we'll do, we'll go back to this option here, and instead of die we'll change this to metric tab. And the moment we'll change this to metric tab, you can see now this thread cutouts is getting cut inside the body. So this is the way to do, like otherwise it will give you an error, right? Now I am completely done with it. I will make sure that here the things are correct, like cut thread and then the right handed thread. So most of the times we use right handed threads only. So these are the some specification about the thread that you should be aware of these things. I will click on finish, and the moment I will click on finish, here you can see the thread just got applied onto that face from bottom until to the top. Like if you want to apply some screw, nut, bolt, anything onto this thing, you can simply apply it. So what we did two-step process. The first step was to adding a hole. The second step was to adding a thread onto that whole face, right? So this is how you can do it. Now, until this point, if you have any question, just let me know into the WhatsApp group. So this part is almost completed. Not almost, it is completed. So you don't have to add any feature onto this right now, and it is done, I think, at this moment. So what we'll do, we'll click on save. I will click on rebuild and save the document, and we are done. Now we can close this part, right? We can close this part. Now we are going to make the second part, right? Now if you remember, when we created the last part that I just closed, we started with a part file, right? We started with a single part file, and then we created that part. Now the next part that we are going to create, if you remember, this is the part that we are going to create. So for this next part, and this next part is going to fit onto our the recent part that we have just closed. So since both of the parts are going to fit with each other, then definitely there should be some matching dimensions between them. Otherwise, they will not fit, right? So how we can find or remember that dimensions, or how we can extract those dimensions and details to model this part. So this is what I'm going to do, explain you now, right? So we'll go back to our SolidWorks. So this time, instead of starting from the part file will start with a assembly file, right? So we will go back to the file menu, we'll click on new, and instead of starting from a part file, we'll click start from the assembly file. Here you can see. So don't worry, if you have any questions or queries about how and what are the steps we have to follow to start an assembly file, don't worry. In the next session, that is on session 5, we'll have a detailed discussion like how we can import the file, how we can start a new assembly and everything into the next session. So you will be getting a complete description, complete explanation into the next session about the assemblies. But in this part, right now we are only going to explain you about this simple part file, right? So again, I'm repeating, at any point of time, if you got any questions, you can just let me know. And just give me a second, I'm coming back. So here you can see we just started assembly file. Don't worry about anything. Simply go into this assembly tab, assembly tool panel, and click on this insert component. Just follow the steps, because in the next session I will be explaining you the complete step by step process. But for this step, these steps are not important. The most important is how we can make a mating part that will fit with the existing part. So that is the main thing. So simply click on this insert component, then close this, go over here and click on browse, and then insert your part that you just created. So here you can see right now on the day today we have created this part. So I will click on open, and before, here you can see the moment I clicked open, this part is attached with my cursor, and from using these options we can rotate our part. So right now the orientation is already right, so we don't need to rotate. So we'll simply go on to this eye icon that you can see onto the top, and just after it there is a small drop down. Click on it and turn on these two options, these 3 axis and 2 axis option, and then again click on this small drop down to hide that thing. And here you can see this two small blue axes, right? One attached with the body and one is attached with this drawing space, right? So what we have to do is we have to move our cursor close to the this axis, like the one that is attached with the drawing. Simply move your cursor close to the origin point of it, and automatically it will both origin of both the parts, that is for the origin for the drawing space and origin for the part, will get aligned. So simply move your cursor close to it and then click. So here you can see that this part we just inserted into this assembly file. Now the next thing is that the moment you will import or insert your first part into the assembly file, on the left side menu, here you can see in the design tree, just before the beginning of this part name, there is a small minus icon inside these brackets, right? This means this part is free to move inside this space. Minus icon means this is a free to move inside this space. So what you have to do here is we'll press Ctrl J to bring it back, and what we have to do here is we have to fix this part into this space, and for that we'll make a right click onto it into the design tree, and here we will option to click fix. So I will click fix, and here you can see the icon just got changed as F. This means this part is now fixed inside this space and we cannot move it. Here you can see even if we'll click on it and try to drag, we cannot do that because we just fixed it into this space. Now the next thing is that since we fixed this part into this space, now is the time to create our new part or new component. And how we can do that? Simply again go back to the assembly tool panel, and under the insert panel click on this drop down icon, and there we have an option for new part to start a new part into this assembly file. So I will click on new part, and the moment I will click, here you can see in design tree a new part just got added. But I will simply press escape first, and then I will make a right click on the new part and rename it first. So let's give it some name. Let's say I will write it a holder, and here you can see I renamed it as a holder. And the new part is still free to move inside the space. I had not fixed it, and you can fix all the parts into your assembly, but I prefer to fix the first part only into the assembly. So now I will make a right click on this holder part that we just created, and right now that part is completely empty. So I will make a right click on it and will click on edit this part. So I will click on edit this part, I will click OK. And the moment I did that, here you can see this is now the active part, that is the holder assembly, and the main body is now all wireframe, or you can say it's less transparent, just because this is not active, right? And we cannot make changes into it because right now we are active inside this holder assembly part file. So now we'll start making this holder assembly part file, and for that what we'll do, the first thing, we'll go on to the sketch panel. Right, we'll go on to the sketch panel and we'll click on sketch, and then we'll select this face, the face of this existing part as a sketch face. I will click on it. Right, so here you can see now we are ready to start creating the sketch, but I don't want to create. Okay, let's create new sketches. So I will activate the line tool from the sketch panel, simple line tool. Here you can see I will start from this corner. So here you can see, since this part is just acting as a reference, still we can click on the any corner point of these parts or any edges, right? And that is why I am following this approach. So by using this process I can use the dimension of these parts, and the new part that will is going to fit into this part easily. That's why I'm taking the reference of all the dimensions and the edges and the lines from this existing part only. So that's why I will create a line from this point to this, like this. Here you can see something like this, then it will go like this. So you have to create a sketch like this simply using the line tool, and the sketch tool will be active until you will press escape onto your keyboard. So here you can see, so I ended my sketch onto this point, and then we'll click on here, we'll click on here, and then here, and then here you can see how easily I am creating the parts. And now the profile is closed. Now I can press escape. So this is the sketch we created, so kind of thing that will hold on to the existing part and will able to slide into that rail. Right, now I will simply here you can see there are some problems. I want this point, I want these is and this is to be on a same label. So for that, we'll select this corner point like this. And also by pressing shift on my keyboard, I will also select this edge and will apply this coincident constraint. Here you can see. I will also make sure that this line is perfectly vertical. So we'll select that line, we'll apply this vertical constraint like this. Now I want this line and this line to be equal in size. So I will select both the lines by pressing shift on my keyboard and will apply the equal constraint. Here you can see both of them just became equal. Also we'll do the same for these two lines. We'll apply the equal constraint like this, and we'll also do the same for these two lines. We'll select the both the lines, we'll apply the equal constraint for them as well like this. Now here is our design. So if we try to adjust this one, here you can see the other is not adjusting. Still I had applied all the equal constraint, still it is not adjusting. So the next thing that we're going to apply, we'll select this point and this point, and we'll make sure that both are horizontally aligned. So we'll apply the horizontal constraint, we'll click on finish. Also we'll do this for the same 2 points, horizontal aligned. Also for these 2 points, horizontally aligned like this. Here you can see. Now I also want this part to be, this line and this line to be perpendicular to each other. So we'll select both the lines by pressing shift on our keyboard. Here you can see, and we'll apply this perpendicular constraint. Right, so it's giving me an error anyway, no problem. So let's adjust it manually. Okay, so here you can see we are able to move it. Right, we'll move it little bit towards downward, and we'll make it something like this. Now what I will do here, I will activate my line tool, and from this point I will create a line like this. Here you can see a simple line that is connecting onto the front edge. Now I want this line and this line to be equal in size. So I will click, I'll press shift and will select both the lines and will apply the equal constraint. And here you can see, because of that, this became equal. This distance is consistently equal. Also, we'll select this line, we'll change this to construction line because I just created this line for the reference. Now we'll do the same onto this side. We'll create a line like this from this edge to this edge, and we'll make this line perfectly horizontal, and also we'll make sure that this line and this line are equal in size. So I will apply the equal constraint between them. So only thing that is now is not constrained is this blue line. So first we'll change this to construction line. Let's define the dimension of this line. So from the top we can define it from here, let's say to here. Let's make it 20. So we'll write 20. Now everything is completely defined. Now I will simply orbit it little bit so you can see what is the profile we created. Here you can see this is the profile we created, right? We'll go back to the features tab, we'll activate the extrude tool, and it will start extruding this, but it is extruding it in the wrong direction. So we'll flip the direction using this tool, and then we'll change this to 15. We want to make it 15 millimeter thick in thickness, width you can say. I will click on finish. So here you can see this is the part we created, right? Now the next feature that we want to create, here you can see this extended is with the cutouts. The same thing we'll try to replicate onto this face. So for that, again we'll click on this face. So the one way to start a sketch on any face to add any feature is to go to the sketch tab, click on the sketch tool, then select the flat plane or face. The other way, if you don't want to go with all these processes, the shortcut to do that is simply click on the face and then you will be able to see a box like this. So the moment you will click, and these box will be there for few seconds only. So the moment you will click, instantly go into the box, and then into the box you can see there is a tool called sketch. So if you click on this sketch tool, it will start creating a sketch onto this face. So let's see how I am doing. I will click on the face, will click on the create sketch. Now we are ready to start creating a sketch onto that face. I will simply use this corner rectangle tool, and from this corner to this corner I will create a random rectangle first. Then I will make sure that this rectangle is touching onto the edge of this, so we'll apply the coincident constraint. Now I will make sure that the 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 width, or you can say the height of this part, should be equal to the height of this rectangle. So for that, what we'll do, we'll go normal to it, and we'll make sure that this edge should be aligned with this edge, right? So the bottom point of this edge. So for that, we'll select this corner point. Let me select the corner point. So anyway, if I cannot select, what I can do, I can measure the distance and I can apply that dimension over here. So how we can measure it? There is a tool inside this evaluate panel called measure. So activate this tool, select this top face, and then select this bottom face, and it is giving you the distance between these two faces, that is 15 millimeter. Right here you can see that. So press escape to come out of the tool. Go back to your sketch tool panel, activate this smart dimension tool, and dimension this is as 15, 15. I'll press enter. There you can see exactly same. Now we'll click on finish sketch. We'll go to the features extrude, and this face will extrude by 5 millimeter. I will click on finish. So if you'll measure the extended region over here, this is also 5, whereas the 2 millimeter is the depth of these cutouts that we're going to make now. But before that, we'll apply this chamfer that you can see onto this face of 10 millimeter. So we'll go back to our fillet and we'll activate this chamfer. We'll select this corner edge and we'll apply a chamfer of 10, and we'll click on finish. Here you can see like this, right? So it's very similar to what you can see right now here. Now before we'll move forward, will apply these chamfers of 2 millimeter on all the internal edges, because that is important. And for that, we'll again activate this chamfer tool, and this time I will select all the edges where we want to apply a chamfer like this, here you can see. But we'll change this value to 2, and then again come back to this box, and we'll keep adding all the edges where we want to apply this chamfer, not on this face. So anytime if you have selected any wrong face or edge, you can simply click on it again to deselect it. It's very simple. And these things you will be able to learn only once you will keep practicing. Right, here you can see somehow by mistake I selected the complete face, so I will click on it again to deselect it, and the rest of my selection will be available. Here you can see, so these are all the edges that I wanted to select. I will simply click on finish. So how I know that we have to select these edges or that edges, and it's completely onto me, since I am the one who is designing this part from scratch. I can take my decisions, right? So it's not, if you are reverse engineering any part, if you are copying any part, in that case you have to see that part and measure its features. Otherwise you are completely independent to take your decisions, like where to apply fillets, where to apply chamfers, what hole size you have to keep. It's completely onto you, because you are a design engineer, right? You are the person who is designing the product. So completely responsibility is on your end. Now here you can see we just finished this one. Now the only thing left for this part, now two thing left. The one thing is to apply a hole onto this face. So if you see the example, you have to apply a hole and apply a thread onto it. Also we have to make a cutout over here like this. Here you can see, so to make it cutouts, what I will do, I will click on this face and will create a sketch onto that face. Right, here you can see, so we'll start creating sketch onto that face. Here I will simply create a 3-point rectangle first, like this. I will make sure that this angle is at aligned at 45 degree. So I will apply the angle over here as 45. Here you can see. I will also make sure that the thickness of it is 1, right? Because in these cutouts also I think the thickness is 1. So not 1, I think 2. It should be 2, right? So we is whether it's 2 or 1, I don't think it's 2, it's 1. Let's keep it 1, right? Or else if you don't know these dimensions, then how you can check it? Simply go to the home and open the part that you did. So I will open the last part that I did, and I will go and check into this part. Like, this is the sketch we use to create the part, and we'll edit the sketch. I can check all the values. This is 1, right? The gap between them is like from the end it is 1.5, and then the gap between them is 2. So we can check it, we can close that part. I just opened this for the reference, and now we can come back to our design. So here this is one end. Now if we'll go back to our sketch tool panel, and we'll add this dimension from this edge to this, this is 1.5, I think. So let's add that dimension again, repeat, from this is to this is, this is okay. So it's giving me an error. Anyway, let's do it. Yes, we can move it. We'll go back normal to it. We'll activate the sketch dimension tool. From this is to this is, this should be 1.5, like this. Now we are going to pattern this one. So we'll activate this linear sketch pattern, and then in the direction, first I will delete this x-axis using my delete key on my keyboard. Simply select it, and delete key on your keyboard will delete that. Then select this horizontal line as a sketch pattern direction. Right, now enter the values. Let's say I want to keep 6 or 10, so I will enter the values 10. And then in the distance I want to keep 4, so I will make 4. And then what entities you want to pattern, so I will select all the edges one by one, 1 2 3, and this bottom is 4. Here you can see, now you can see the pattern option over here, how it is visible, right? You can clearly see it. So let's make it to 3, I think, not 4, 3. or maybe 4. I think 4 was good. Yes, and increase the numbers. We want to cover the whole face, so let's make it to 13. Not 13, I think 12 should work. 12 is working. I will click on finish, and here you can see. So this is the face we created. Now simply go back to the features tab, activate this extrude cut tool, and it is extruding but much higher. We just want 2 millimeters, so we'll change that to 2 millimeter. Now here you can see this is how it is extruding inside the body. I will click on finish, and it will make a cut. So here you can see we got the same pattern onto the opposite side also. So whatever the objects we are keeping between these two jaw will getting folded uh, firmly, I will say. So here is the thing. Now the next thing, if you remember, we have to create a hole of size 12 millimeters that should be aligned with the center of these holes. So if we are inserting any screw, right, they should be aligned together. So for that, we'll go back to the hole wizard. We'll activate this hole wizard tool, right? And then we'll select in the position, we'll select this face, right? And now we have to find the point where we have to create that hole. And for that, what you can do, simply go back to your visual style tab onto the top, change this to wireframe. Here you can see. Now go back to the convert entities tab and click on this circle and click on finish. So this circle just got projected over here, and now you can check the origin. Now activate the position tab from here, go back to the type and then again position, right, and click on this face, and then click on the origin point of the new projected sketch. Here you can see. So here we'll go back to the type, we'll make sure that the diameter is 12 and rest of the things are 100% correct. I will simply click on finish, and we just created a hole. But again we have to change the visual style to shaded with edges. Here you can see like this. So we created a hole, but this hole is perfectly aligned with the front hole. Here you can see, perfectly aligned with the front hole. Now we have to apply the thread onto it. The same process. Go to the features tab, activate your hole wizard tool, activate your thread tool, and then the moment thread tool is activated, select the starting edge of your cylindrical face, and you can see the preview of the thread. But that should be blind, that should cover the whole length. Here you can see it's not covering the whole length, right? So here what I will do, I will change this to, instead of changing this to something else, what you can do, you can increase these values. Let's make it 15. So now it is covering the whole length. Let's make it a little bit more, 16. So here you can see it's covering the whole length, right? And it is also inside the body, means it's cutting from the body. This means we are able to get the thread. Simply click on finish, since this is the detail we want to keep. And here you can see we just created a thread that is completely aligned with the front hole, and we just finished this part. Now we'll click on exit part, and the moment I will click on exit part, here you can see this is the main body part and this is the new body part just that we just edited. So this is the part you have to finish inside your sketchwork environment, inside your 3D modeling workspace for today. Now before we'll move forward, I will make a right click on this part and we'll click on this save part in an external file. Right now it is getting saved as a stem assembly because this part we have created inside the assembly file type only. But now we'll click on the save part in external file, and it is getting onto the same location where this main assembly file is, main body part is. So I will click on OK. Okay, so that part just got saved into that folder. Now if we'll go back to our folder, here you can see, if you go back to our folder, you can see inside SolidWorks project. So this is the new folder part that we just created on the date 9/8/2025. Here you can see. So this is the new part just that we just created, and here it is. So this is your work to create this part, and that should be completely matching with the existing part. Here you can see here it is completely matching with the existing part. So even if you try to make it assemble with this part, we can do that. So but that assembly thing and how to apply assembly, how to insert components, what is the process, and all those things we are covering into the next session, that is on day 5 session. But before that, I want you to practice these parts. Try to make these parts onto your end, and let me know into the comment box, into the chat box, if you have any questions. Into the group, you can post your question into the group. You can post into the communities like LinkedIn, Facebook, Instagram. You can tag me. You can tag our page 3diest 3diest, and we'll try to answer that. We'll try to solve your problems and queries instead of randomly searching on the internet. So this is what we can do. So here you can see these are the two parts we just created. These were very simple parts. Still, I think it's very useful to get started into the SolidWorks. Just by making these two simple parts, you will have lots of knowledge to start making parts that can be practical, that can be manufactured like a design engineer. You will start thinking, and you will start designing like an actual design engineer, and that is my goal for this complete bootcamp. So now if you have any questions, just let me know. Otherwise, we can wrap up this session. And again, I'm repeating, this recording, once this day is finished, on the next day you will be able to find the complete recording onto the same dashboard. Just go into your this academy.3dash.com, and then log in, and under my purchase section you will be able to see. If you'll go on to this SolidWorks, you will be able to see all of your recordings. So here you can see until day 3 the recording is uploaded. For day 4 we'll add this recording for the today, and these things you can access for almost 365 days from today. So these recordings will be available for free to access to you online up to 365 days. So keep learning, keep watching, and also finish this assignment, finish this work that I had assigned over here, and we'll see you in the next session, guys. This is what I can say. Thank you so much for learning with me. We'll see you in the next session. Thank you.